This movie shows how to use the review results module of Wellbore simulator. After a run has been made, the results will be written to a file with extension .owb, and this review results program allows us to look at the results of the run. So when we click on review results, we have to select a file from which we can now populate these boxes in. And we want to select a file, open the results file, and for example we can open up a file with the ICD in it and open the file, and then for reading the file it identifies the reservoir is always here and what pipes are present in the run. The pipes information are displayed here, and you can select one or more. You can select several, click and drag down, or using a control click you can select several ones. And this side here are the parameters that you can select. This will be the pressure, temperature, saturations, local subcool, oil rates, water rates, gas rates, steam rates, energy rates flowing into the segment. Corresponding series of oil, water, gas rate flowing out the segment, and typically what flows in will flow out as there's no accumulation in a steady state program. But just to show the possible material balance error, the in and out series have been put in here. The mixed fluid density to see the head gradient inside the wellbore, the steam quality flowing in and flowing out, the liquid rate, the measured depth, the true vertical depth, the energy rate in steam going in, energy rate in steam going out. So this is to give you an idea of the heat released by condensation as steam condenses in a segment. On this side here, we can save a report selection so that we can open up another file and use the same report selection. We do not have to re-choose these pipes and this series every time we open up a file with similar piping configurations. So we can save it and then we can retrieve it back using the get save report selection. We can change the number of decimal places for the output if we want to have more decimal places or less decimal places. And if we so choose to, we can display a colored Wellbore schematic, colored based on number of intervals, and you can save the color palette file. You can define the color palette file, but you can optionally display the Wellbore schematic colored for each of these parameters in the range of colors based on the range values in the pipes. So if we were to choose, in this case here, we were to choose the reservoir and say pipe 1 and pipe 3, for example, we can look at the water rate flowing in and the water rate flowing out of the segment. And if you show the report, well, this shows the tabular report of the parameters we've selected. We selected the reservoir flowing in, reservoir water rate flowing out, pipe 1, water rate flowing in, water rate flowing out, the long casing, the long tubing string in and out for water rate, and at the top here we have the point summary. So in this well configuration we have, in this case here, this is a steam injection case, and we have a injection point in the short pipe, an injection point in the long pipe, and this identifies for us where the segment number that we're injecting in, the status of the well on, the type of well is injected, not a producer, the calculated injection pressures, and this identifies for us that this pressures were used at the segment 1, the oil rate, water rates, gas rates, dry steam rates, and the heat rate injected. So the injection is negative, the production is positive, so we're producing from injecting into the well and producing into the reservoir. So this is the sum of all the rates going in or out of the reservoir. This is sum of all the rates through injection points, and this must balance this, and this is the net. This is the net of all this, and if this net is not small enough, it will show that this is a material balance error. So if you look at this net and you see that the net is a significant number that you're not happy with, then there is a material balance error happening in the program, and you should rerun the program with a smaller tolerance in order to reduce the net rate. Now for the steam rate, this is slightly different. The steam rate, of course, condensation happens inside the wellbore, and so the net will not be 0 in this case for steam rate. But for this oil, water, and gas rates, the net should be close to 0. And again, heat rate too. The heat rate, if the net is not close enough to 0, you may consider that you want to rerun it with tighter tolerance. So what we have here is the reservoir in and out. And so you can see what, as water is injected into the reservoir, it flows in, but nothing flows out. So for the reservoir in and out, it has a number, but not for the out number. Now for the pipes have in and out, and usually the pipes would be almost identical, showing that there's almost no accumulation. So the difference between the casing, the in and the out, this is what goes out into the reservoir. So that's what flows into the reservoir. For a long tubing string with no perforation in the pipe, we will see that you would have in and out is very close to each other. In and out is very close to each other. Now similarly, we also identify colored pipe. So all this is one pipe, one color. All this is one reservoir. This is a long string, and this additional coloring. Red is for plug segment, and here in the casing we have plugged the segment here. Green is for an ICD section. So this is ICD, where fluid escapes from the long string into the liner. And again, the difference between the in to one segment into next segment, that difference is what is flowed out into the casing liner. So you can choose the various series to look at for example, the pressure and the water rate. You can see what the values are as a table, and you can copy and paste these values to Excel spreadsheet or for further analysis. If you want to graph the data, you can also show the graph of these parameters. You can pick and choose from, say, the pipe 1, and you can choose, say, the pressure and, say, the water rate flowing in for all the pipes, and you can select the series. So for each pipe, the two selected series, and then you can delete series if you didn't want them. So you can select series and delete them. If you have measured data, you can also add measured data series here for comparison of the model calculated results versus the measured data series. You can display this series as a graph versus X or versus Y. So show that as a graph versus X. You can see the profile, and you can take some time to review this when you do this yourself. If you want to copy these results to Excel file, you can also do it from here. Utilities, display values as table, and you can get all the values as a table that you can now copy over to Excel for further manipulation. And if you want to display a pipe schematic, you can display a pipe schematic, and this will color the wellbore based on the values here, and you would just click for the segment that you click. You can get the particular values at that segment that goes from right across the system. And you can display a different parameter. Next parameter, in this case water rate. You can see that this is the long tubing string, and the water rate is constant until it hits the ICD. The ICD goes out through here, and you would have a split flow that goes into the liner, and the rest of the flow goes out over here. So this is most of the features of the review results option of the thermal Wellbore simulator. Feel free to play around with this program, because you cannot lose data. You cannot lose data. It's all been written out to file, and you cannot lose any data. Thank you.